Parallel circuits often have knowns and unknowns, and oftentimes the technician needs to take what is known and see if they can't find out exactly what the unknown part of the circuit is. For example, I have some question marks on lines, and we're going to see how we can find those particular values. We want to know this branch current. We need to know what the value of the R2 resistor is for this load. We're going to calculate the total amount of power. We have the total amount of power, or total amount of current. This is the total amount of power given, and we want to find out what the power dissipation is for this particular load out here. Let's take a look and see how we could use a combination of Kirchhoff's current laws, or we could use Ohm's law to figure out what these unknowns are, and maybe come back and check a little bit to ensure that if you have one, you can calculate the rest of the circuit using that calculated value. In example, we have a 10-volt source. This first load is R1, and it's going to be labeled at 10 ohms. This load out here, we're going to label it as R2, but we don't know its value, so we'll take a look at that. But we do know that the current going through this branch is 0.5 amperes. As we take a look at the different things that we're looking for, let's calculate this very first one to find out what the branch current is for R1. So as we're looking at current, one of the easiest ways to find this particular one is to go V divided by R. And we're going to label that I1. So in the case of I1, we're going to use 10 volts, the applied voltage, which is pretty much calculated as the same across each branch current load. I1 is calculated as 10 volts divided by 10 ohms, which results in 1 ampere. So I'm going to relabel this down here. I1 is equal to 1 ampere. And the next calculation, we want to take a look and find out how can we calculate R2. It's a little bit different from a series circuit. You can't just simply subtract the particular value from the main or the total amount of resistance. You have to calculate this a little bit differently. And in this case, we're going to use what's known as the inferred method. In fact, a lot of these calculations are based on inferred method, which means that if we're trying to find out what this value is, so we're going to have to use two knowns to calculate it. And also, Ohm's law works well for this. So let's take the 10 volts, and we're going to look for R. 10 volts. And we're going to divide that by the amount of current, which is 0.5 amperes. So R sub 2 then becomes 10 volts divided by 0.5, which results in a 20 ohm load. So R sub 2 up here is 20 ohms. Anyway, we really have a lot of values that we can work with. Let's see if we have enough to continue working with how much branch currents that we have that find that total amount of current here. So on this very first one, we had 1 amp for branch current 1. We have 0.5 amperes for branch current 2. We do know that as we take I sub t to calculate it, as the sum of the branch currents and any others that are on there, you just add them on. In the case of this particular circuit then, I sub t will be equal to 1 ampere plus 0.5 amperes, and that's going to result in 1.5 amperes for the total amount of current. We're going to put that value right up here, 1.5 amperes. We're also looking for the amount of power dissipation for this particular load here. We have now derived our resistance, the 20 ohm resistor. We do know that there was 0.5 amperes flowing through it, and we have 10 volts across it. Using any one of the three power formulas, I squared R, V squared over R, or V times I, we can find out what the power dissipation is for this particular one. Or if we do know what the total amount of power is, we can actually subtract one of the others and find out what that power is. So let's take this first one. We'll calculate the piece of 1. We're going to take 1 times 10, it gives us 10 watts. If we actually have the total amount of power dissipation of 15, and we subtract this, actually we can find out what the power dissipation is of this load by the deductive method, subtracting 1 from the whole. In the case of this one right here, we want to find out what p sub 2 is. We're going to take p sub t, total amount of power, we're going to subtract p sub 1, and we're going to actually come up with the power dissipation for this branch current out here. P sub 2 then is going to be equal to 15 watts, what was given to us. P sub 1, which we just calculated at 10 watts, gives us with the remainder of 5 watts. And many other types of examples and actual circuit problems, as you work through them, these are how you will actually find what these unknowns are, is by working with what you do have and seeing what is left.